Parameters of sample proportions. Consider a large population, such as the population of Australia. A proportion of this population will have a particular trait, say left-handedness. Whether any particular individual shows a particular trait is a Bernoulli trial. You're looking at one individual, and they either do or don't. If we take a sample which is small in comparison to the population, the probabilities will change by such a small amount that we could consider the number of individuals in the sample that show the trait to be binomial. Now remember, for the binomial distribution, you need a constant probability of success. However, here in this situation, with a small sample in comparison to a large population, the probabilities change such a small amount that we could consider the distribution to be binomial. Let x be the number of individuals in a sample that show the trait. Then the expectation of x would be NP. So if we consider the sample proportion, i.e. the number of individuals who show the trait, divided by the number in the sample, that's going to be NP over N, and note we're using P hat here because it's a sample proportion, which is equal to P. And remember, that's the population proportion. In the same way, the variance of x is NPQ, so the variance of P hat would be NPQ divided by N squared, which is PQ over N. And therefore, the standard deviation of P hat is the square root of PQ over N. And remember, of course, that Q is 1 minus P. P is the probability of success, Q is the probability of failure.